Welcome to Geometry. This is lesson 3.4. We'll be discussing translations in this lesson. As you may remember, there are four types of transformations. The first one is called reflections. We learned about reflections in lesson 3.2. The second type is rotations. Rotations were covered in lesson 3.3. Our today's lesson is about the third type of transformations, which is translations. And lastly, we will discuss dilations in lesson 3.5. A transformation that maps any 2 points P and Q to points P prime and Q prime so that these properties are true, and those properties are as follows. Let's say your pre-image is PQ, your image is P prime Q prime. You connect P and P prime with the green dashed line, and you do the same with Q and Q prime. So now you get these two dashed lines or dashed line segments. The length of those two line segments should be exactly the same. And that's what this statement indicates. Also, the same two line segments have to be parallel to one another. And lastly, those two line segments are going to be in the same plane or they're going to be on the same surface. A translation is an isometry, which means the shape and the size of the pre-image does not change when it's mapped onto its image. Translations in the coordinate plane can be described by this mapping notation. Let's say if you have a point with the xy coordinates of x and y, its image or point P prime, it's going to be the xy coordinates of x plus a and the y coordinate of y plus b. This means that if you have a point in the coordinate plane, that point has to move in the x direction by the amount that a indicates, and it will move in the y direction or up and down based on what b indicates. For example, if we have this line segment PQ, and if we translate line segment PQ by 4 units to the right, that means a is equal to 4. And if we move that point down by 2 units, then it means b is equal to -2. So b is a negative number because we want to move the pre-image down. If it were up, then it would be a positive number. So if we were to draw that movement, then P would be moving to the right and down. The same thing happens for Q. Q would be moving 4 units to the right and 2 units down. And that's how you get the image, which is P prime, Q prime. Use the coordinate notation to describe the translation of a point with the coordinates of x, y. Let's say the pre-image would be P onto its image, which is P prime with the coordinates of x plus a and y plus b. So if the movement in the first case is 4 units to the right and 3 units up, then it means the a value is +4 and the b value is +3. So you will be mapping your point to a point with the x coordinate of x plus 4, the y coordinate of y plus 3. In the second situation, you'll be changing the xy coordinates to x minus 1 and y plus 1. In the third case, your xy coordinates will change to x minus 7 and y minus 4. It's a minus because you're moving the point to the left, and it's y minus 4 because you're moving the point down by 4 units. I'm going to let you finish this practice problem for the other 3 situations, and when we come back to the class, we can look over the solutions. Let's look at example 2. If we were to translate the triangle ABC with the following mapping notation, xy changing to x minus 3 and y plus 4, what would we get? Let's start with corner A. Corner A has to move along the x-axis, but to the left side because you have -3. And you also have to go 4 units up from there, which will give you this point here, A prime. If you do the same thing for the other 2 corners as well, you get this triangle A prime, B prime, C prime. And if you were to write the xy coordinates of the pre-image, which is in blue, and the xy coordinates of the image, which is in red, you will get the table shown here. Now, this is for you. In this practice problem, you do the same thing. Here, you're translating triangle ABC using mapping XY to x minus 3 and y plus 1. Then after you've completed the translation, write the new coordinates in the table. I'm going to demonstrate one of the translations for you, and you can complete it for the other 2 points. Let's start with point A. Here we have x minus 3. That means I have to move A along the x-axis, but in the negative direction by 3 units. I stop there, and since I have y plus 1, I have to move up by 1 unit. So A will land over here. This will become my A prime. Now you do the same thing for B and C. After you get B prime and C prime, go ahead and connect all 3 points and highlight the image for this triangle. Now I'm going to introduce a new term which is called vectors. A vector is a quantity with magnitude and direction. A vector has an initial point, like point P, and a terminal point, like point Q. So this arrow indicates a vector. There are some quantities in nature, for example, the speed of wind, that have both a magnitude and a direction. If you think about the speed of wind, we talk about how great the force of that wind is, and also we talk about the direction of it. When the wind blows east-west at 4 miles per hour, we indicate the direction and the magnitude both. So speed of wind is a vector. Vectors have 2 components. They have a horizontal and a vertical component. So this is the horizontal component, and that is the vertical component. So in this particular example, the component form of vector PQ is written with these pointy brackets. These pointy brackets show that we're talking about a vector. The first number is for the horizontal component, and the second number is for the vertical component. So this vector indicates movement along the horizontal direction by 5 units, and in the vertical direction by 3 units. Let's look at this example. Name the vector and write its component form. In the first example on the left, we have vector mn. The way we write it is with mn and a bar that looks like an arrow. This is very similar to a ray, but it's not exactly a ray because we have these signs here. So it shows that this vector has a horizontal component of positive 4 and a vertical component of negative 4. In order to get from m to n, you have to go down by 2 units, which is this negative 2 here, and you have to go to the right, which is positive 4. In the second example, the vector's name is PQ. The starting point is P, the end point is Q, and the component form is 4 in the horizontal direction and 1 in the vertical direction. In the last example, we have vector RS. We have only a vertical component in this case. Therefore, the horizontal component is 0, and the vertical component is negative 4 because we're moving down. Now let's see how this topic of vectors applies to translations. Let's say if you're asked to translate this triangle ABC by vector 4, 2, let's see how we can accomplish that. Vector 4, 2 indicates that all of the corners, all the vertices have to move in the x direction by 4 units and in the y direction by 2 units. Since they're both positive, that means we're moving to the right and up. So if we repeat the same kind of movement for all 3 vertices, these are going to be the images. A will turn into A prime, B to B prime, C to C prime, with the same type of movement, 4 to the right and 2 up. And when we connect those points, those images by line segments, we get triangle A prime, B prime, C prime, and the new coordinates for each vertex are given accordingly. So this is for you. You need to translate triangle ABC by vector 2, negative 5. That means in the horizontal direction, you move to the right by 2 units, and in the vertical direction, you move down by 5 units. I'm going to help you with point A, and you can complete this practice problem for the other two vertices, and then you can connect up the new vertices and draw the image. So again, let's say start with A, for example. So A will move 2 units to the right, 5 units down. So that's 1 unit, 2, 3, 4, 5. So that would be A prime. So go ahead and finish this practice problem, and let's review your results in the class together. Let's look at the example 5. In this case, we have quadrilateral QRST mapped to Q prime R prime S prime T prime by a translation. The image is also shown in red. We're asked to write the component form of the vector that made the translation. As you can see, T was moved to T prime with this green vector. This green vector has a horizontal component and a vertical component. Its horizontal component is, let's see, 1, 2, 3, 4, 5, 6, 7, 8 units to the left. So that would be -8. And then you would have to move up by 2 units. So that would be +2. So the vector would be -8, 2. In this practice problem, you need to write the transformation in its coordinate form and write it in its vector form with the components of the vector. In other words, one time you need to determine if you had x, y changing to x plus a and y plus b, what those a and b values would be. And the next time you need to write it in its vector form. That means if you had a vector that determined your movements, let's say if your b is changing to b prime and this is the vector, determine what the horizontal component is, you write that here, and determine what the vertical component is, and you write that over here. You can pause the video and complete this practice problem. Now let's come back to the solution for this practice problem. So hopefully you have figured that for B to move to B prime, or A to move to A prime, or C to move to C prime, what you have to do is you have to move in the horizontal direction or in the x direction, in the positive direction of x by 5 units. That's 1, 2, 3, 4, 5, and 2 units up in the vertical direction. So your xy would change to x plus 5 and y plus 2. And if you were to write it in its vector form, it would be 5 in the horizontal direction and 2 in the vertical direction. And they're both positive. I'm going to end this video at this point. The rest of the notes will not be covered now. I'm going to discuss double reflections in parallel lines in person. That brings us to the end of the video. I will see you in class. Thank you.